Hi, today's goal is to evaluate numerical expressions using what's called order of operations. You're going to need your note packet for evaluating numerical expressions in front of you throughout this lesson. If you don't have your notes, or at least a notebook ready if you forgot your stuff or are not able to get to it, hit pause, get something to write on so that you can take your notes along the way. All right, our goal for today. Evaluating numerical expressions using order of operations. So starting with, we have three basic types of math problems. We talked a little bit about our expressions in the last lesson, things that have numbers, operations, and sometimes variables involved, not including an equal sign, not including an inequality sign. So our three types of problems. Expressions can be any combination, numbers, letters, and stuff to do with those numbers and letters. Equations are two of those, right? Two expressions, and then in between or separating those two expressions is an equal sign. So as soon as you see this symbol, it's no longer an individual expression. It's two expressions with an equal sign in between called an equation. And then same thing, if you have two of those things called expressions, and you have one of these four inequality signs of greater than, less than, greater than or equal to, or less than or equal to separating, you now have what's called an inequality. Everything that we're doing here in Module 2 or Chapter 1, depending on where you're learning, is going to deal with what's called an expression, a math problem with no equal sign and no inequality symbol in it, and how we go about evaluating, more specifically, the type of expression that's called a numerical expression. Because within expressions, we have two categories. Numerical expression says, I just have numbers with my operations. Right? With my numbers, am I adding, subtracting, multiplying, dividing? Is there a power? Things like that. Variable expressions, remember, that can contain at least one letter and sometimes more than that. So for right now, we're just focused on this top type of expression. I have all numbers and stuff to do with those numbers. How do I evaluate to get down to one big final value? That's our goal for today. So if we have, again, these are two types of expressions, all numbers and stuff to do with their numbers. That's what we're looking at today. We'll get to these problems that have individual variables in there and how we go about evaluating, because our process is a little bit different when there's letters or variables in the problem to start. So how do we go about doing that? If you're taking notes at home right now, hit your pause button, fill in your magic blanks, and then come back to us. All right, now that your blanks are filled in, thing number one, if your original problem is one big fraction where there's some math to do on the top and some math to do on the bottom, your first step is to group. And by grouping, we just mean use a set of grouping symbols to make the top an individual problem and the bottom an individual problem. We're going to look at one example like that today. I promise it's going to be the most common missed sort of step I'm asking you to show on your piece of paper. Once you have things grouped if needed, from there, you're working inside what are called grouping symbols, right? Just what you would have used up top: parentheses, brackets, curly braces. Absolute value bars are a grouping symbol. Square root signs can be a grouping symbol, right? So you're working within anything that groups math to do. Inside the grouping, you have to follow this special order, so just be careful. It's sort of an order of operations problem within an order of operations problem, so be careful there. Once you eliminate the work on the inside of your groupings, then you're going to things that were originally on the outside that are powers or things that have exponents. Then from there, you're working through your multiplication and division. Here's where people are going to mess up. You are not doing all the multiply, finishing that, and then looking for the divide. You're looking for both of those, multiplies and divides, and you work through them from whatever's farthest left to whatever's farthest right, so be careful. Same thing with your adding and subtracting. The most common mistake would be to just do all the add, then go back there and do all the subtract, which is not the case. You're looking for both at the same time, and you have to work through them from left to right, so be careful. So our goal for today is working through order of operations. I like to use PEMDAS as my way to remember things. This letter P, some people use G for GEMDAS, which means the same thing, which is grouping symbols. P for parentheses or G for grouping symbols. Parentheses, brackets, curly braces, and so on. Then you're looking for things that have powers or exponents. Then from there, things that are multiply and divide. L2R just stands for go from left to right, or we're going through this direction through the problem. Left to right. Same thing with your add and subtracting. You're looking for it from left to right. We're heading this way, and we're knocking out each add and subtract problem along the way, heading from left to right. We're reading it like a book. So let's look at some examples. Remember, for your doing first thing, which is your grouping symbols, there are a whole bunch of different types. Parentheses, brackets, absolute values, square roots, curly brackets. You're looking for all those. And then inside of these, you're doing math following this special order, so just be careful. From there, you're looking for exponents, your multiplies and divides next from left to right, and then finally your adds and subtracts, again, from left to right. So example number 1, if you need to, hit pause, copy it on down. 9 squared plus quantity 145 minus 5 times 3. We want to evaluate until we get down to one final number. And the way that we do that, when there's just numbers, called a numerical expression, we follow this special order of operations. So I'm looking for grouping symbols first. Inside of here, these parentheses only count as grouping symbols, or do them first here in order of operations if inside of here there's actually math to do. Because sometimes parentheses are showing us that a number is negative. Sometimes our parentheses are just showing us multiplication. So you have to look and say, inside my grouping, in there, is there actually some stuff to do? Is there math to do? If there is, then it's this letter P for grouping symbols or parentheses. So in this case, there is an operation inside or some math to do. So we start there first. All we're going to do is this 145 minus 5 on our first step. One change per new line on our piece of paper. So we're going to bring everything else down to completely unchanged. 9 squared is coming down, plus is coming down. We're going to do the 145 minus 5 part. We'll get 140. And we're going to bring down the times and the 3 portion. All right. If there were more than one set of grouping symbols, we would use that same left to right rule. And we would do the set that's further to the left, everything inside of it, get rid of it, and then we would go to the set that's further to the right and do everything inside of it. All right, in this case, there's no other grouping symbols, so we'd say, all right, we've eliminated P for parentheses or grouping symbols. Now we're looking for anything that is a power, or something that has a base with an exponent. That's what this letter E stands for. So right here, we have a 9 squared. It's our next step because it has an exponent attached. It's the next thing we have to evaluate to get our final proper value. Everything else is coming down unchanged. All we're doing is the 9 squared portion. So this 9 squared, which is 9 times 9, would now give us an 81, not an 18. It's not 9 times 2. It's a 9 times another 9. Bring down the 140 and the times 3. All right, now I'm looking to see if there's any other exponents, because if there are, I would have to work through them from left to right using that same rule. In this case, there was only one, so I'd say, all right, I'm done with exponents. Now, I'm looking for both of these, multiplication and division. If there's more than one multiply or divide in the whole problem, we do whatever's further left and work all the way to what's furthest right. In this case, we have an add and a multiply, so there's just one multiply, no divide also, so we're going to attack that next. Bring everything else down unchanged. We're doing the 140 times 3, and we should get a 420. So we now have 81 plus 420. All right, no more multiplication, division. We're left with one last addition. Again, if we have multiple additions and subtractions at this point, we'd work through them from left to right, so be careful there. All right, last step, 81 plus 420 would give us a grand total here of 501. All of these are required steps. You don't have to show the little carrots underneath, but you do have to show all those individual steps along the way. All right, number 2. Again, if you have to hit pause, get your problem copied in, go ahead and hit pause. 16 divided by the quantity 2 plus 3 times 2 plus 10 squared minus 27. I want to evaluate down to one number. Since there's just numbers here called a numerical expression, PEMDAS or order of operations is the thing that helps us. All right, so we're looking for grouping symbols. Again, we want to look at our parentheses and say, are those just parentheses or are they grouping math? If they're grouping math, we have to attack what's inside of them first. So inside of here, there is an add and a multiply. So yeah, it's grouping some math. I'm going to attack the stuff on the inside of there first. Now, there are 2 things in here, so I can't just go left to right. I have to think, what order would I have to do that problem in using order of operations? So inside of here, I have to look at my order over here and say, which one would happen first, the adding or the multiplying? The multiplying is first. We have to do this 3 times 2 portion first. Everything else is coming down unchanged, including the parentheses, because we haven't finished our work in there. So 16 divided by 2 plus 3 times 2 is now a 6. Don't forget your parentheses is still there. We haven't finished everything inside there yet. Plus our 10 squared minus 27. All right, we're not quite done with our parentheses here. So we have to keep working. There's still some math grouped inside of there that we have to finish before we do anything with anything that's outside of our grouping symbols. So we need to finish here. Since we're going to finish everything inside on this next step, the parentheses will now get removed when we go to our next line because we're finishing them. So bring down our 16, divide. 2 plus 6 would now give us an 8. We can leave the parentheses, but they're just no longer needed anymore. Bring down our plus 10 squared and minus 27. All right, we have no other sets of grouping symbols. If we had a second set, we would work from whichever one was farther left over to whatever's farther right. All right, now we're looking for things that were originally outside of our grouping that have a power or an exponent, which is right here. That's all we're going to change on our next steps. 16 divided by 8 plus 10 squared is 10 times another 10, so 100, and then minus 27. If we had a second power exponent, we would keep working from left to right to finish them. In this case, we don't. All right, we're looking for multiplies or divides in this case, and looking to go from left to right. We have a divide here, no other multiplies. So we're working right here. That's it for this multiplication and division. 16 divided by 8 then would give us a 2 plus 100 minus 27. All right, now we're looking for everything that's left, which is just our adding and subtracting. And more specifically, we're going to go from left to right through them. So 2 plus 100, so 102 minus our 27. And then we would finish by doing the 102 minus 27, which would give us a 75. Even if this was the subtract and this was the add, we go through them from left to right. We don't skip over the subtract to go to the add, which is a common mistake. We're looking for both of these, and we have to attack them, whatever's farthest to the left and work farthest to the right. All right, number 3, last go. All right, these are rational numbers because they're in fraction form, right? The ones we've looked at so far were integers, positives, negatives, or even you would describe as being counting numbers because they didn't have decimals or fractions attached. When you have what are called rational numbers, in this case fraction form, it doesn't change anything about the process of your order that you're going to attack the problem. This ABC button, if you have a calculator like the one I suggested to get, is the one that is going to help you type in what are called mixed numbers or fractions. In this case, they're in mixed number form, where there's a big number part and then a fraction part attached. If you don't have that, you can use the button on our Schoology page. That is the scientific calculator that will take you to a calculator that also allows you to type in these mixed numbers. So that takes away sort of the tricky part of the problem, and we're still just focusing on the order that we attack. All right, we're looking for grouping symbols first. A couple things here. This is a subtraction. This is a negative number, so just be careful when you type things in your calculator. This number is directly touching our bracket here. When a number touches any grouping symbol, like a bracket or curly brace or parenthesis, and they're side by side and there's nothing else there, that's showing you multiplication. So my suggestion would be put a dot or something here to show your multiplication. Because when the brackets disappear, you still have to account for the operation that is hidden there of multiplication. All right, so we want to start inside here. There's one subtract problem, so we don't have to really think about an order. We just have to do that particular problem. So I'm giving you, again, some keys on your calculator. If you have the one I suggested buying, the Texas Instrument version. Most calculators that allow fractions have buttons very similar to these, so you're going to have to navigate through. So 5 1/8. 5, your fraction button 1, your fraction button 8 would help you type it in, minus your 6 1/5. And then when you hit enter, it's going to give you back the simplified version of that, which is a -1 3/40. And then everything else is coming down unchanged. So we still have this -3 1/5. We still have a -2 1/2. And then don't forget, this right here is not a subtract, this was a times. And that's why I suggest right away putting that multiplication in there. Because if you don't bring that down, you're going to leave this as a subtraction problem and then obviously finish the problem incorrectly. So just be careful there. All right, we're done with our grouping symbols. In this case, there are no exponents. There is a multiplication, so we want to go there next. All right, we're doing this +2 1/2, right? Ignore that, that's the operation. 2 1/2. times a -1 and 3/40. This -3 and 1/5 is just going to come down unchanged. And this subtraction is going to come down. We'll get there in a second. All right, so a positive times a negative is actually going to give us a negative here. So be careful. And it's going to give us a -2 and 11/16. All right, done with our multiply. All right, all we have left is a subtraction, so we're going to finish there. Some of you prefer to do keep, change, or make it add the opposite. When you get here and you're doing your add and subtract, don't do it way at the top. But when you get to all you have left is adding, subtracting. If you want to make this plus +2 and 11/16, you're free to. You'll get the same exact result as if you type it in like this as a subtraction with a -2 and 11/16. All right, so we're going to do our subtract, -3 and 1/5 minus a -2 and 11/16, and we end up with a -41/80. -41/80. Not pretty, but really not any more complex than the other examples that we did. All right, one more for today. I want to look at one where we start with a fraction to start, where there's math on the top and math on the bottom. This is places we're definitely going to forget to make some of our work or show some of our steps along the way. When we have this, we have one big problem that's one big fraction, but up top there's clearly a bunch of stuff to do, and on the bottom there's clearly a bunch of stuff to do. We have to create two order of operations in one, and the way to do that is to group using a grouping symbol like a parenthesis, a bracket, a curly brace on both the top and the bottom. So I'm going to go brackets here, just so they stand out. So I'm making, hey, one big problem on the top and one big problem on the bottom. So here's your rules for your steps. Each step is going to be a fraction, right? So here's my fraction bar. I'm going to have a numerator. I'm going to have a denominator step. I'm going to do one of my things in order of operations on the top from step to step, and one of my things on the bottom because of order of operations from bottom to bottom, or denominator to denominator. Up here, number touching grouping is a multiply again. I would suggest putting that dot or something in there so that you remember that when you get to that point of the problem. All right, so when we're looking at this top, we have an add, we have a divide, we have an add, and we have an exponent. So I would go over here and say, I have adds, I have divides, and I have an exponent. So the exponent is the first one. So we're going to do this 2 to the 4th on the top of our fraction. So 20 is still there, 12 is still there, divide is still there, 3 is still there, and plus is still there. And we are going to do the 2 to the 4th power. 2 to the 4th, or 2 times 2 times 2 times 2 is just a 16. All right, now we're not quite done with our complete step because we still have to do something in the denominator here. We've got to do something from here to here. So in the denominator, there's an order of operation problem. There's a multiply, there's an exponent, and there's a subtract. There are no grouping symbols other than these big brackets because inside of here, right, that's just showing us that we have something that has an exponent. All right, so we're going to start with our exponent. It happens first. So all we're doing is this 3 to the 3rd on the bottom. So the 5, the times is still there. The subtract 125 will still be there. And 3 to the 3rd, which is 3 times 3 times 3 again, will give us a 27. Bring everything else down. All right, that's step 1. One change on the top and the bottom is one step. All right, so new fraction bar. We need to go back to our top. We have add, divide, add. So in our order here, the divide would happen first. So we're going to do just this 12 divided by 3. So 20 plus 12 divided by 3 would give us a value of 4 plus 16. And we still have brackets. We haven't finished everything inside of there. So these brackets I added at the beginning will be there until I finish all the math on the inside on the top and all the math on the inside on the bottom. So be careful. All right, down here we have multiply and we have subtract, so this multiply would happen first. We're going to start with the 5 times 27, which would give us 135. Bring down minus 125. All right, I'm kind of running out of room here, so I'm going to start a second column of work here, but you should be able to hopefully keep going down in your notes. All right, on the top, all we have is adding left, so we're going to work from left to right. So we're going to start here with 20 plus 4. And we should get 24 plus 16. On the bottom, we only have one thing left to do, which is a subtraction, and it would give us a value of 10. I no longer need my brackets down there because I've now done all the work that was inside of those brackets. Now, it wouldn't be wrong if I left them here. I just no longer need them because once you finish your work inside of parentheses, brackets, and curly braces, they can go away. All right, I'm not quite done on the top, so I'm going to finish my add. 24 plus 16 would just give us a value of 40. So 40 on the top, 10 on the bottom. At this point, we've done one thing in this entire order, which is letter P. We eliminated our grouping symbols. That's it. We did our brackets on top. We did our brackets on the bottom. I know it took us a bunch of things to get there, but that's all we've technically eliminated so far, right? We did order of operations in our brackets. Now, once we get here, we have to still go through. Do we have any exponents? Nope. Do we have any multiplication or division? Yes. And this is where people forget to finish because a fraction is really a division problem. So I could divide, or you could also sort of think of it as I could simplify at this point. So 40, 10. So 40 divided by 10 would give us a final value of 4. No more add, subtract. We're completely done at that point. I will see you guys later. Have fun evaluating your expressions.